very good morning to Dr. Anafi. Today I will be presenting my assignment for MTK3032, Statistics for Chemistry. Before that, let me introduce myself. My name is Lim Wai Loon, ID metric S70917. So from the instructions given in the assignment, randomly select 32 observations from the data bank and show how you have randomly selected 32 observations. So what I do is that I go to Dr. Hanafi's file here and I change it to my name and copy and paste into my own file. So as you can see, this is my own data. And yeah, this is what I used to solve the 6 questions in the assignment. So we go to the first question. Question one is find the 90% and confidence interval for the average serum cholesterol data where the population standard deviation is 22. So by based on this, what I do is that I find the mean by using the Excel command here, where this is the serum. So I round it up everything and find the mean by the command, by the Excel command, where average equal to average and the coordinates. So what I get is 215.406. So I submit it into here, and before that we find the z-score for confidence interval, where confidence interval is 90%, so the alpha is equal to 100 minus 90 and then divided by 100. So the alpha we got is 0.10 and divided by 2 equal to 0.05. In order to find the z-score, we use 1 to minus 0.05, so we get 0.95. And from this table here, from this cumulative standard normal distribution table, we can see that 0.95 is stated to have 1.6 and 5, 0.05. So the value is 1.65. But here we put it as 1.645. The standard deviation here is 22. And then this is the formula for the confidence limit. So we sub in the mean, the z-score, and also the standard deviation, as well as the sample, which is 32. So we get here is 209.008 and also 221.804. Hence, one can be 90% confident that the interval between 208, 209.008 and also 221.804 does contain the sample mean. We move to question 2. Find the 95% confidence intervals of the proportion of education level is graduate degree. So if we scroll down to the bottom part, you can see that the education level values are stated, where 3 is the one stated graduated degree. So we went back to our data and we can clearly see that our number 3 is, there's two number 3 here. If we sort it out for a second, and yeah, there's two number 3s, two value of 3s. So we consider that the P is 2 and the Q is 1 minus P, so it has 30 divided by 32. So same thing, confidence interval equals to 95%. So we find the alpha by 100 minus 35 divided by 100. So we get 0.05, and 1 minus 0.05 divided by 2, we get 0.025, and then 1 minus it, we get 0.975. So from the same table, cumulative standard normal distribution, we can clearly see that 0.975 state that the value 1.96. So here we put 1.96, and this is the formula used in this question. P sub in 2 divided by 32. The z score 1.96, P 2 divided by 32, Q 30 divided by 32, and the N is 32. So all we get is negative 0.0214 and also 0.1464. However, there is no negative in percentage, so it's convert it into a zero. Hence, we can be 95% confident that the percentage of education level of graduate degree is between 0.14%. We move on to question 3. Find the 95% confidence intervals for standard deviation for weight of male respondent. In order to find it, we must come back to the data and we sort it out in this gender data. And we can clearly see that there is 19 male respondent. So 19, we put it here 19. And same thing, the confidence interval is equal to 95%. So 100 minus 95, we get alpha equal to 0.05 after divided by 100. And divided by 2, we get 0.025. And then 1 minus 0.025, we get 0.975. And then we get the same z-score, which is 1.96. So from this, we can use the chi-square distribution table to find the degree, to find the value where 18 and 0.975 is 8.231. So here we write 8.231. So for 0.025 and 18, we get here 31.526. Yeah. So we sub everything here. This is the formula used for this question, where n minus 1 is required. So here I minus the sample by 1, and then I sub in directly. Uh, in addition, I also find the standard deviation by the Excel table. So I submit everything. And then the last but not least, we get 5.205 and also 10.186. Hence, we can 95% confident that the true standard deviation for weight of male respondent is between 5.205 and 10.186. So question number 4, test the hypothesis that the average serum cholesterol is different from 215 mg percentage at alpha equal to 0.05, where population standard deviation is 22. So here we can clearly state it that the H noun here is 215 mg and the H1 is not 215, which is not equal. So the alpha is 0.05, so divided by 2 is 0.025, so the critical value is same thing, 1.96. So the critical region here is that we reject H noun if the value in test statistic obtained is lower than 1.96 here or higher than 1.96. Lower than negative 1.96 or higher than 1.96, sorry. So the mean is still the same, 215.6406, and the formula used is here. And we submit everything, we get 0.1044. Since the test statistic value lies in the range of negative 1.96 and 1.96, so we do not reject H now. Therefore, there is insufficient evidence at the 5% significant level to support the claim that the average serum cholesterol is different from 215 mg percentage. Question 5 is there any significant difference on average serum cholesterol between male and female respondent at alpha equal to 0.02, assume different variance? So by this, we need to go back to our data again, and then we already sort out this two gender. So we can clearly see that male has, there is 19 male respondent and 13 13 female respondent. So we write it here, and we take the lower one, 13. So we minus it with 1, so we get 12. And we minus this male respondent also, we get 18. So the alpha here is 0.02. So the same thing, we get the z-score of 2.33, where critical region is lower than negative 2.33 and higher than 2.33. So sample 1 is female, sample 2 is male. We state the mean and variance here. And the test statistic formula here is stated here. So we submit everything, we get the value of test statistic is negative 1.3236, which is between the negative 2.33 and 2.33. Since the test statistic value lies in the range of negative 2.33 and 2.33, so we do not reject H noun, where H noun is no difference between the average serum cholesterol between male and female, while H1 is not equal, which means there is significant difference. So if we do not reject H noun means there is no significant difference. Therefore, there is insufficient evidence at the 2% significant level to support the claim that there is significant difference on the average serum cholesterol between male and female at alpha equal to 0.02. So question number 6, build a simple linear regression between Z equal to serum cholesterol and Y equal to systolic pressure. So in order to solve this question, we go back to our table, data bank, and we find the sum x for sum x considered as serum, while y considered as systolic. So we find the mean here and the variance here, also the sum x here. Same thing goes to the systolic. So for sum xy, what we do is that we times up these two together, which is 242 times with 149, we get this value. So we pull it with the Excel command and we get the sum xy 90 909,013. So we put these values all together here, where the formula used here is y equal to a plus bx, and the a formula is here, b formula is here. From a, we submit the values for the sum x square, sum y, and sum xy. So we get a equal to 96.0344, while b also, we submit everything, including the sample. The sample is 32. So we get 0.1649. So the equation of the linear regression is y equal to 96.0344 plus 0.1649x. So pretty much that's all from my assignment. Thank you for listening.